Okay. Okay.
Yes.
Thank you. Yeah. So this figure shows that a schematic diagram of a smart street lighting system. So a smart street lighting system consists of a center management system, so called CMS, like here, and then the this CMS to operate and management on it, and a street light which were connected to the CMS via wired or wireless communication. And the last one is that a smart LED head like this with various sensors and IoT devices to provide lighting control and other smart city related services. The first of all, CMS kind of brain for smart street lighting system. It can play a role for management and monitoring the smart street lighting system. Generally, based on that, the local mapping and visualization software, the CMS conducts commissionings, grouping, and controlling a specific single street right and a set of grouped street rights also. Moreover, it serves the writing control on demand, on schedule, on events, and other smart city related services. Okay, the next one is that smart pull and head. So nowadays, various environment sensors, CCTV, EV charger, and other smart IoT devices are merged into the LED head and pull. The left figure shows that example of such a smart pull and head. It called a humble lamp first and integrated with various IoT devices according to the relevant applications. Based on such a smart pole and head, traffic like this, traffic, weather, air quality data were obtained, and smart parking, the emergency response, asset management, and security services are provided using such a merged IoT device with a smart pole and head in street lighting. Okay, our next part is a communication protocol. So to provide these functions and services, essentially these street lights must be connected to the central management system. So up to date, various wired and wireless communication protocols are candidates for the smart lighting protocols. So for example, the PLC and DALI are generally used for a wired network, and an RF mesh and a cellular, for example, 4G and 5G network, and narrowband IoT, and LoRa is also used for the smart street lighting already. So there are many competing protocols. So it is kind of a bottleneck to establish the uniform, the smart street lighting. But there are in the market there are already many protocols used in the specific cities also. Um, this part is kind of applications using the smart street lighting applications. So for example, the lighting services itself, because that essentially the smart street lighting is kind of lighting basically than the other smart city services. You can see that various services for the traffic monitoring and irrigation for the water and the humidity, temperature, and moisture in the city. And you can get monitoring that air quality to manage that air level, air quality of the city, and a smart sensor to check to any kind of assistance. And Also, that is kind of waste management to eliminating the garbage trucks to schedule how to gather the waste in the city. So you can see the various kinds of applications in the smart city based on the smart street lighting system. So you can see that here there are kinds of applications, for example, basic lighting controls and advanced lighting controls and environmental quality monitoring, the traffic monitoring, the smart parking, waste management, traffic light controls, so public messaging over the digital signage, and the gunshot detection and location detections, and moreover that CCTV also. So you can see that in this table, you can see that how much cost for the upfront and ongoing, I mean the management for such a application in the smart city, and require the reliability levels and the security level and the power requirements and latency requirements and most of the bandwidth requirements. So you can provide these kind of applications using the smart street lighting, but you also need to do that. You also need such a kind of requirements. So, for example, the CCTV is consume most bandwidth and the power in the merged IoT device in the smart pole or smart head in the lights. Okay, so I provide the applications using the smart street lighting, and also the kinds of that communication protocols. Now we check that the strengths of and weaknesses of such communication protocols for specific lighting application. For example, you can see that here this kind of technology from that narrowband to broadband communication protocol technology, and you can call it kind of bandwidth. Then you can see here so specific applications, for example, basic lighting controls, advanced lighting controls, traffic monitoring, smart parking, and so on. So this column shows that overall stability of such protocols for specific applications. So the color means that green means that very suitable, and then the red means they're not suitable at all. So for example, maybe the best candidates for that environment monitoring, traffic monitoring, and smart parking is using the PLC protocol or RF mesh or hybrid PLC and RF mesh is best candidate such applications. So why you using the smart street lighting for such applications as a backbone of smart city? Because that's the street lighting connected to the powers and widely evenly distributed, and where people are, there are also that the smart street lighting and easy to connect and good sensing position for that environments and other sensors, and creates people the safety for that using the smart street lighting. This is the reason why people think that smart street lighting as a backbone of smart city. So now you have transfer options to the smart street lighting system. For the baseline, there are several generation for the street lighting. For example, level 1 means that's traditional lighting, and level 2 means that's LED street light, and then level 3 means smart lighting, but not for that the connectivity and the smart city services. Level 4 focus on the smart riding with a smart city and with connectivity functions. So the benefits of such smart street riding is the energy savings with smart riding controls, the environmental benefits as a result of lower greenhouse gas emissions, and the public safety benefit associated with more responsive lighting levels, so also enabling smart city use cases and products. But to do this, that you need you should pay the cost. For example, lighting controller, the CMS cost, connectivity cost. I mean that the cost for that communication protocol and hardwares, and smart city hardware and application cost. So even then, potential cost for installation of smart city hardwares also. So now I provide some case studies. So what is the baseline from the level 1 to level 3, for example? So you can see that for cases 1 is as you can you may find a Silverstring company report. So they changed it to from the level 1 to it means that from the traditional lighting to LED lighting. So the description means LED replacement only in this case. So payback year is about 8 years. The benefits and energy saving compared to the normal traditional lighting alone. So next study is Dublin City Council. They transferred from level 1 to 3. So means that traditional writing to the smart writing. And the payback year is about 8.6 years, and the benefit is 7% energy saving compared to the normal LED installation. So generally, generally that 40 or 50% energy saving uh, using the LED installation compared to the traditional lighting. So it is in this case about 60% energy saving compared to the traditional lighting. Next case is San Diego City in the US. They transferred from level 1 to 4. So in this case, the installation of LED street lighting with connectivity and smart city applications, the payback is about 13 years because it costs so many hardwares and softwares to do that. And the benefit is dimming schedule to reduce the light and other providing other the smart city related services. And the other case studies from the Silver Spring company also, they transferred from the level 1 to 4. So the payback years about 6 years. You can see that the first case, transfer from level 1 to 2, payback years about 8 years, but the same company to level change from level 1 to 4, the payback years is 6 years. So um, or 2 years are reduced to for that payback years. So because this comes from that additional financial savings driven by operational savings, as well as energy savings from dimming and reduced nightly burn time enabled by the network also. So this case, there are already a kind of certification program, but not so many. The example for this certification program is DLC, Design Light Consortium from the US. So uh, they certificates about network lighting control system. And you can see that requirements in that two category. One is required and the other is repetitive. So required means a mandatory one, and repetitive means that the optional one. So for the exterior, I mean that outdoor lighting system, your lighting system should be network network connected by network in luminaires and devices, and occupancy sensing or traffic sensing, and daylight harvesting, the photocell control, and high-end trim, journey, individual addressability, and continuous dimming, scheduling also. So there are tons of systems already got this kind of certification. You can see that light figures. So you can see the company, for example, Curie Brands, Enlighten, and G Currents, and Hubel Lighting Company, and so on. So you can see also that there are functions, for example, that's network control, occupancy sensing, traffic sensing, daylight harvesting, and so on. So you can see the more information that below source at www.designlights.org, lighting controls. And this is example of the certified products in case of Hubble lighting company, and the control system model is Wiscape. So you can see the summary. There are so many functions and controls. And for example, they provide occupancy sensing using that PIR technology. And you can see that they have a traffic sensing and the daylight harvesting functions and high-end trim from minimum 1% to 100% or so. And now we check the current situation in the world about the smart city. You can see the top 10 cities implementing smart street lighting in the world. For example, that Miami in the US is ranked 1. So they have about already 50,000 smart street lighting, and Paris ranked number 2, and Madrid, Los Angeles, Jakarta, Montreal, Birmingham, Dongguan, Buenos Aires, and Milan also. So this is popular smart cities in the world implementing a smart street lighting uh, and providing the related smart city services also. So now we take a look around the Korea's case. We have some smart city projects in Korea also. For example, Busan, the south part of the Korea, uh, they done a project about smart city Busan using that smart street lighting network. So they wanted to check. They wanted to use that kind of management for the smart city level. For example, the illegal parking control, emergency detection, and accidental push notification services, and to check the urban air environments, noise and light pollution management. And so you can see that the disaster detection, for example, earthquake, natural disaster detection services. And they wanted to use the smart street lighting infra for the city asset management service also. And there are some examples for the city parking, city traffic, lighting, safety and security, and so on. Next case is Sejong City, the middle of the South Korea. So they, you can see the figure. There are the pilot street, smart street lighting streets using that CCTVs and sensors and IoT devices also. So their object is to reduce 80% of energy saving energy compared to the conventional street lighting, and cut about 50% of maintenance cost. And safety means crime prevention using the smart street lighting also. So on-site emergency alarm to reduce that crimes or offense not intended. And the other case is Seoul. Seoul is most biggest city in Korea. So they have a plan to replace all street lighting to LEDs and uh, uh, IT-based outdoor lighting control system. So their target is that switch all public use lights with switching on-off functions and dimming and monitoring function also. But private use lights for the private use is so not is the monitoring is not prohibited in such a case. And now I talking about that markets, the smart street lighting markets. You can see that a regional market size from this year to about 10 years. So nowadays the biggest market it is in the Europe and Asia Pacific, and then about average the CAGR is about 26.6 percent, and so that units is $1 million. You can see that a very huge market in the future for the smart street lighting. And we think about it, the future application using smart street lighting, for example, a public Wi-Fi system, so environmental monitoring, and EV charging, and even some people think about the drone charging station like this. Okay, that's the final page prepared by my side, but I have some supplements. For example, the mappable LED lighting standard in IEC. So you can see that here, so LED package, LED module, LED lamps, and LED luminaires. So relevant so standard for safety and performance. You can check that current situation of the IEC standard for the LED lighting. So next one is characteristics of electron light sources for that conventional lighting, for example, low pressure sodium and high pressure sodium and metal halide to the current LED electric light sources. That's the reason why we should change, or so many cities change to that from the conventional to LED street lighting. And even there are some concept about how to classify the smart street lighting, because there are so many functions and services using the smart street lighting. So this concept from the DIN spec, it means that kind of a official document from the Germany. They have a concept for that such a smart street lighting, the classifying several classes. For example, so there are, you can see that class 5, number 5 means that can serve as a EV charger point or a drone charger point and energy storage stations. So when you cover the specific functions or services, then you are street-wide classified as such a relevant class numbers. Okay, thank you for attention. And okay, my name is Jongmu Kang for the test Korea Test Certification Institute, and I'm the co-convener of the IC TC34. SC34A working group 3 OLED light sources. Thank you very much.
Thank you for presentation, Dr. Gang. Please ask if you have any question. Anybody have questions to Mr. Gang?
Okay. Anyway, you may contact to me via emails, or when you have any questions or ideas, do not hesitate me. Okay.
Okay, if you don't have any question, we're going to next step.
Thank you.
Thank you. Next is Professor Yu Chan of Bugyang National University. She will present Introduction to Photometric LED Lighting, Part 2. Mr. Dr. Yu, please.